Hello, friends. So today we are looking at modeling linear functions. So let's get started. Take a look at these two scatter plots. What do you notice is different between these two scatter plots? Well, let's look. We've got the point 1, 3 here. It's still there too. Okay, so 1.5, 2. Yep. So from what I'm looking at, the scatter plot is exactly the same. So what's the difference between A and B? Yes, they are different lines of best fit. Take a look at A and B. Which one do you think is actually the line of best fit? Okay, so why do you think that? When we're looking at A, I have 1, 2, 3, 4, 5 positive. And 1, 2, 3, 4, 5, 6, 7, 8, 9 negatives. Do you feel like there's an equal amount above and below the line? Yeah, no. 5 positive and 9 negative. Those are not equal. So now let's look at B. We've got 1, 2, 3, 4, 5, 6, 7 positives. And 1, 2, 3, 4, 5, 6, 7 negatives. Yeah, line B, that's actually the line of best fit. Line of best fit is when you have an equal amount or as close to equal as possible for each of the positive, the dots above the line, and the negative, the dots below the line. All right. So if I'm thinking about line of best fit, the best way to find line of best fit is with a graphing calculator. So I'm going to use this table here. The table shows temperatures, X in degrees Fahrenheit, and number of people at the beach. So first off, do we feel like there's a correlation here? Okay, absolutely. There is a correlation. Is it causational? Does the temperature affect the number of people at the beach? Absolutely. Not many people are going to want to be at the beach when it's 0 degrees outside. So it does have a causal relationship. So I'm going to pull this over onto my other screen, and I have pulled up from Canvas. I've clicked on Big Ideas Math and gone to the math tools. The math tools have several different things that you can use, but this one right here, Desmos Graphing Calculator, is the one I'm going to be using. So we're going to put in a table. So I'm just clicking this plus right here and clicking table. And I'm going to put in the information from the table that I just showed you. And all I'm doing is putting in the X values and the Y values from the table. It takes me just a minute. 86, 380, 90, 490, 92, 430, 95, 570 people, 97 degrees, had 510 people, 99 degrees, had 560 people. All right. So now I can plot those points. Yeah, you can't see them. Why? Because my range is too small. So I have to zoom out. And here we start seeing our scatter plot. So when we're looking at this scatter plot, and I can move it so that you can see it a little easier, do we have a correlation? Yes, Absolutely. What kind of correlation do we have? Yes, we have a positive correlation. As the temperature increases, the number of people at the beach increases. So now we're going to go down to this one and we're going to find the linear regression. We're going to find the line of best fit. And we're going to use that slope intercept y equals mx plus b. It's a little weird because what we have is not a function. So we can't use equals. And notice that in this table, they have the subscript 1. So I'm going to use that y subscript 1. And I can't use equals. So I'm going to use shift and the button above the tab to do a tilde. Those of you that habla español, you understand a tilde says nye instead of ene, right? So a tilde in math means approximates m x1 plus b, right? So this is finding that line of best fit. So it uses the technology, it finds and uses all of the points available to find the slope and the y-intercept. So the slope is 13.059 and the y-intercept is negative 723. Yeah, no, that doesn't make any sense, right? Because the y-intercept is when the degree mark x is 0, there will be negative 723 people at the beach. Yeah, how do you have negative 723 people? That just is the line of best fit. So I have the machine actually has graphed this line of best fit. I'm going to zoom out just a little bit. We can see that we have a very strong correlation. There's 1, 2, 3, 4 maybe that are positive. 1, 2, 3, 4 maybe that are negative. So this is actually a line of best fit. Tomorrow, we are going to use some examples out of your book to understand how to know, is it really a good line of best fit? And then also looking at how do we interpret that slope and that y-intercept. So if I'm looking at the one here, I know that x is the temperature and y is the number of people. So it would be as 13 more people are coming to the beach, it's 1 degree warmer. That would be that slope. And that y-intercept is at 0 degrees Fahrenheit, there are negative 723 people on the beach. Now, if you looked at interpolating and extrapolating last night, you know that this is an unreliable, unreasonable expectation. You're not going to have negative 723 people. If what I just said sounds like some foreign language, no worries. Feel free to watch the video again. You will want to be able to do this on the Desmos graphing calculator that you will have access to on your test. It's in your big ideas. Let me show you again. In your Canvas, click on big ideas. It comes up and math tools is one of them. You want to go to graphing calculator and you add a table to put your table in, and then y sub 1, because see that little sub 1 right there? Tilde, not equals because it's not a function, m x sub 1 plus b. It'll give you your slope and it will give you your y-intercept. You can then put it in slope intercept and you can interpret points on the graph. Have a great day. You are going to be, for class, doing the 4-6 extra practice and the 4-6 puzzle time. They are front and back on the worksheet that you should be handed. If you're not handed one, go get one out of the algebra box that's on the front board underneath your algebra objective. Make sure you get that. Make sure you finish it. Submit it to Canvas using your computer. There will be no phones today because I am not in the classroom. Have a great day, and I will continue to explain another time. Bye.